Hi, in this video we will learn about basic operations for matrices: sum, subtraction, scalar multiplication, and equality. Let us start with the equality of matrices. When we say two matrices are equal, two matrices A and B are equal if, first of all, we denote it by A as it is A equal to B as equality. If this happens, this is very common sense, yes. If they have, first of all, the same dimensions, and they have same dimensions, so they have the same number of rows, the same number of columns, and the entries, the corresponding entries are the same. So the corresponding entries are the same. Well, it means what? If I denote entries of A by Aij, and it is M by N, and matrix B by Bij, and it has K rows, L columns, then we say A is equal to B if and only if these two happens. The number of rows are equal, M is equal to K. The number of columns are equal, N is equal to L. And this means that they have the same dimensions, yes. But it's not enough. We have to make sure that the corresponding entries are the same. So Aij, the entry at ith row, jth column of A is equal to Bij for the entry on ith row and jth column of B. So that's, as I said, for all, this is for all I and J's, possible I and J's. Yeah, this is very common sense, as I said. The second thing we cover is what is sum of matrices. So we want to add two matrices. It is going to be done entry wise. The first entry, the entry on the first row, first column needs to be added to the entry on the first row, first column. But to be able to have everything added, we need to first make sure that they have the same number of rows and columns. We can add any two matrices with the same dimensions. If they don't have same dimensions, the sum is not defined. The first row is not, you may have more rows, then you cannot add them. Okay, and if you have A equals to Aij and B equals to Bij, the entries, both of them first of all need to have the same dimensions. They need to have same rows, same number of columns. Then when you add them, the resulting is again a matrix with the same dimensions, M rows and columns, and the entry at the ith j row is equal to Aij plus Bij. Means what? Means that add the corresponding entries and put in the corresponding place. Let's just see in an example. First, if I want to add this matrix 1, 2, 0, -1, 0, 3 to negative 1, 1, 1, 0, this is not defined, yes, because the number of rows for the first one is 2 and number of columns is 3. For the second one, 2 times 2. If they don't have the same number of entries or the same number of rows and columns as a result entries, this sum is not defined. So this, let me just write, it does not make sense, or it's not defined. Well, if these guys they have the same rows and same columns, then that's a different story. So if I have 1, 2, 0, negative 1, 0, 3, let's call that A, and then B is negative 1, 2, 1, 3, 2, 4. Then when you add them, first of all, they have the same number of rows, the same number of columns. The resulting matrix is going to have 2 rows, 3 columns. And then what do you do for the entries? Add the corresponding entries. 1 plus negative 1. 2 plus 2. 0 plus 1. Negative 1 plus 3. 0 plus 2. And 3 plus 4. And, well, this way you define the sum. Okay. The next thing is that multiplication by a scalar, So if you choose any matrix, let C be a number or a scalar, and A be an M by N matrix, such that the entries are denoted by Aij. We have M rows, N columns. Then C, my C is not good. It needs to be lowercase, so small, not capital. Then C multiplied to A defines a matrix. It will have the same number of rows and same number of columns, M by N, as A. And what are the entries? The entries are the product of that constant to those are the entries of A. So in other words, if I call this guy here up there A, this is B, so the example says that what will happen if you multiply 2 to A, or what is 2 and 3, say negative 3 to B. Well, just multiply component wise, yes, so the entry wise in this case. So 2 times 1 is the first row, first column. 2 times 2, 2 times 0, 2 times negative 1, 2 times 0, 2 times 3. This gives us 2, 4, 0, negative 2, 0, 6. How about this other one? Well, let me just write it. Negative 3 times negative 1, 3, negative 6, negative 3, negative 9, negative 6, and negative 12 is negative 3 times B. If you remember what we did in the case of vectors, you'll see that a special case of scalar multiplication is the negative matrix. Yes, the negative of a matrix. So if you write, when you say negative of a matrix, what you mean is that negative 1 multiplied to A. In other words, if entries of A are Aij, you multiply all the entries by the negative sign. And when you have negative sign defined, right away you can do the subtraction of matrices. So matrix subtraction. By what do we mean by that? So if you have A, B, first of all, they need to have the same number of rows and columns. So M by N, M by N. Then the subtraction means you add A to negative of B. In other words, you add A to negative 1 times B, and if we have the same convention as before, this means that you subtract the corresponding entries of the matrices. So these are the basic operations we have for matrices. The properties of these, the properties of matrix operations. It's very similar to the numbers, at least when it comes to addition and subtraction and scalar multiplication. For example, if you add matrix A to B, it is the same matrix as if you add B to A. It's commutative. The second thing is that, well, if you multiply A by C plus D, it will give you the same result if you first multiply A by C and then multiply A by D and then add them. This is distributivity, yes. And the other way, we have another distribution form that scalar distributes over the matrix addition, and then as a result of that, if you have, well, not as a result, sorry, this is another property that scalar multiplication and just product of numbers work nicely together. Another property is that if you multiply number 0 to any matrix, you get a matrix, 0 matrix, a matrix which has the same rows and same number of columns as A, but all the entries are as 0. And for the last thing is that if you add A to its negative, you get 0 matrix. So if you start with M by N, you will end up with M by N 0 matrix. So these are the properties, the basic properties. We have more things to add to this. One thing is called transpose, and another thing is matrix multiplication, which we will learn in next videos.